All right, let's go ahead and focus on convergent boundaries. And I'm hoping we can do all three in one video, but we will see if they fit. You might have to break up between two videos. The first one for convergent plate boundary is looking at the continental to continental convergent plate boundary. And for this one, this is where we are dealing with land or the continents, right? So it's where we have two, not necessarily continents, but two parts of a continent coming together. So you have it going in this direction as well as the other plate moving in that direction. And this could all occur on the exact same continent, right? It's just one plate that is composed of continental crust and another plate that's composed of continental crust are moving toward each other. And with this one, what actually happens is since both continental crusts have the same density, when they move toward each other and they collide, they're actually going to be forced upward, right? Because one can't go underneath the other one because they have the same densities. So it's the same thing with air masses. If you have two air masses that have the same densities and they come together, you're not going to have one rise and one sink because the densities are the same, right? They're basically just going to kind of battle it out in quotations. And these plates basically do the same thing, right? So they're almost going to battle out, they're going to collide. But when that happens, they're going to have to crumple and fold because they have to go somewhere. And the only place for them to go is up, right? So basically they're forced upwards, they're going to crumple and fold, and that's going to build the mountains that we see. If we're looking at an example of using Play-Doh plates, which is what you guys are going to do tomorrow, you're going to create the Play-Doh plates. In terms of thickness, you have to make sure you represent this with the same thickness because we're looking at both continental crusts, they have the same densities. And when you take this plate and move it toward this plate, the only thing that can happen is that they're gonna fold upwards and they're gonna crumple and fold, right? That's the only thing that can happen because the densities are the same. Go ahead and pause the screen and record this information in your guys' document. You can either do it by hand or, here. And I'm actually looking at this spot right here, the continental to continental convergent. In terms of drawing your guys' pictures, again, make sure you include the arrows to show the directions that the plates move, and then also make sure you show kind of like the upper carrots, I guess, is what we want to call them, to show that mountains are being created. Or if you want to include a picture of a mountain in yours, that's fine too. But you have to represent somehow that mountains are getting created with continental to continental convergent plate boundaries. If we look at a real life place, the Himalayas are a very great place when we talk about continental to continental convergent plate boundary. And this is all occurring on land, right? They're not necessarily, it's all the same continent, but we have different plates that are actually located here. So we would have maybe this plate moving in this direction, this plate is going to be moving in that direction, and you can very nicely see where those Himalayas fall, right? That's going to be a plate boundary. So that's going to be a boundary between two different plates. And, since this one's moving in this direction, this one's moving in that direction, the only thing that these two plates can do when they collide is they're going to have to crumple and fold. If we can kind of just see if maybe we can find a location on the Himalayas, if it will allow us to. Let's try to see if we can drop it here. Right, hopefully we can kind of see, again, it's okay, so we're seeing kind of mountains in this location. This might not necessarily be the best image, but it's still kind of neat that we can actually view what it's like there, even though we can't actually travel there, right? That's kind of the exciting part for me. Okay, so these would be some examples of Himalaya mountains. This obviously probably isn't the biggest place, but the main thing, we see mountains there. That's the important part for us. All right, let's go ahead to the next example. So this one is the continental to continental. Let's now take a look at the continental to oceanic, right? And then the one right after this is oceanic to oceanic. And these two convergent plate boundaries do very similar things. They do what we call subduction. And this is where you have densities, the densities of the two plates are different. So one will actually subduct under the other one, which is kind of cool because, you wouldn't really think that plates that compose Earth can actually do this, but this is what happens. It's just like air masses in the atmosphere. When you have one that's more dense, it's going to sink. When you have one that's less dense, it's going to rise. This is just kind of how nature works. And the plates on Earth do the exact same thing. So go ahead and go back to your document, look up where it says continental to oceanic, include this information in there, draw the picture as you would. The biggest thing with this one though, because we do have the densities different, and we have oceanic crust and we have continental crust that come in contact with one another and they collide, that oceanic crust is going to be more dense. The continental crust is going to be less dense. So when they collide, the oceanic crust is actually going to sink underneath the continental crust. And when that happens, the features that we actually get, so this is your continental plate, this is the crust, this is the oceanic crust. Here you can see lines of volcanoes, right? So we can get mountains that get created, like a mountain range. You could have volcanoes here. So the red dots are representing the volcanoes, and those carrots are the upper arrow carrots are representing the mountains being formed. But also what we get, because this subducts, the oceanic crust subducts under the other one, is we get trenches, right? These are very deep valleys that occur in the oceans. And I can show you a real life example of this as well. So make sure you're representing this idea. So go ahead and pause the video and get this information done. In terms of the Plato plates, for this one, what's crucial is that since we have continental crust and oceanic crust, the continental crust is going to be thicker, so you have to represent that, and the oceanic crust is going to be thinner. Their densities are also different, right? This one is less dense, this one is more dense for the reasons that we've talked about before in this class. Now, when this actually happens, so when you have the continental crust moving in this direction, the oceanic crust moving in that direction, when they collide, it's going to, this crust is going to, the continental is going to crumple and fold to create those mountains because they're going to rise upwards. But the oceanic crust is going to subduct underneath. Now here we have the mantle, right? So when this crust subducts underneath this one, it's going to get really hot. It's going to become that molten rock that we kind of looked at before, and it actually just becomes part of the mantle. And when this takes place, I kind of represented it in orange for you here, just so you kind of see it better. So when this part of the crust actually goes into the mantle, it's going to heat up, it's going to become more like a liquid, and then it can actually rise through. If there's any cracks that get created, it can rise through and actually create volcanoes. So that's kind of what we're looking at here, and that's kind of like how the volcanoes actually take place. In terms of a real life example, so if I go back here, this is looking at the Himalayas. Let's go look at an example of where we actually see oceanic to continental. So the only places that we're going to see this is, we can find trenches there, right? This kind of looks like an area that might be a trench. The trenches are a very dark blue area. The best place is actually in South America, right? So you can see that here. We do get some in North America as well. But these are looking at the Andes Mountains. So you can see this really dark blue line. That's a trench, right? So you have oceanic crust here. The plate that the oceanic crust is part of is going to be moving in this direction. This plate that the continent is part of is going to be moving in that direction. They're going to collide. Since this one is more dense, it's going to subduct underneath the one that's less dense. And then you get that trench that's being created, but you also get mountains. Now, I don't think that I can show you guys the trenches and what those look like, but let's see if we can even just get to it, like the mountain area. Right, so we should be able to travel here. We can see, the mountains. Again, we can't really go to the ocean and see the trenches, but if we were able to travel to the trenches, they would be very deep areas in the ocean, right? And that's looking at a plate boundary where two plates actually meet and collide. Let's see. I don't know if I want to move in that direction. No, that's probably not where I want. That's probably just a river. But again, you can kind of see the mountains. I wish we could get a little bit more than just this, but it will work for me. All right, I will have to do one more video, so I will do the last one on the last video. But that shows you trenches.